So, because this is a developer conference, I want to take this opportunity to share with you some things about AI agents I'm excited about. And I'm actually going to share some things I've never presented before. So there will be new stuff here. So, AI agents, right? What are they? Many of us are used to using large language models with what's called zero-shot prompting, and that means asking it to write an essay or write a response to a prompt. And that's a bit like if you imagine going to a person and saying, could you please write an essay on topic X by typing from start to finish all in one go without ever using backspace. And despite the difficulty of writing this way, I can't write that way. Despite the difficulty of writing this way, OMs do pretty well. In contrast, an agentic workflow is much more iterative. You may ask an OM, please write an essay write an essay outline, and then ask, do you need to do any web research? If so, go search the web, fetch some info, then write a first draft, then read your draft to see if you can improve it, and then revise the draft. So with an agentic workflow, it looks more like this, where the algorithm may do some thinking, do some research, then revise it, and do some more thinking, and this iterative loop actually results in a much better work product. And if you think of using agents to write code as well, today we tend to prompt an OM, write code, and that's like asking a developer, could you type out the program and have it just run, from your typing from the first to last character? And it works surprisingly well, but agentic workflows also allow it to work much better. So my team collected some data that was based on the coding benchmark called Human Eval. Human Eval is a standard benchmark released by OpenAI a few years ago that gives coding puzzles like this. Given a non-empty list of images, return the sum data, and that turns out to be the solution. And it turns out that GPT 3.5 on the evaluation metric, parsec K, got it 48% right with zero-shot prompting it to just write out the code. GPT-4 does way better, 60%, 67% accurate. But it turns out that if you take GPT 3.5 and wrap it in an agentic workflow, it does much better. And so, and with GPT-4, that does also very well. And so to me, one thing I hope you take away from this is, while there was a huge improvement from GPT 3.5 to GPT-4, that improvement is actually dwarfed by the improvement from GPT 3.5 with an agentic workflow. And to all of you building applications, I think that this maybe suggests how much promise an agentic workflow has. So my team at Landing AI works on visual AI, and I want to share with you some late-breaking things. I've never presented this before. We just released this as open source a few days ago on what I'm excited about building a vision agent. So the lead of this project, Dylan Laird, is an avid surfer, and so he looks a lot at shark videos. There's a shark, and these are surfers kind of swimming around. And Dylan was actually interested with videos like these, how close do sharks get to surfers? And this is a video generates a video like this. The shark is 6.07, 7.2 meters, 9.4. Now it's swum far enough away, so we switched the color from red to green, and the surface more than 10 meters away from the shark. So if you were to write code to do this, you run object detection, do some measures, finding boundary boxes, plot some stuff. Like, you could do it, but it's kind of annoying. Take several hours to write code to do this. So I want to show you the way we built this video, which was, we wrote a prompt. Can you detect any surfboards or sharks in the video? Draw a green line between the shark and the nearest surfboard. Assume 30 pixels is 1 meter. Mark the line red, blah, blah, blah. This was the instruction given to the vision agent. Given this, the LLM, writes a set of instructions that breaks the task down into a sequence of steps, extract frames by using the extract frames tool and so on. This is a sequence of steps to do that task. After that, we retrieve tools. Tools means function calls. So for example, save video, right, as a utility function that saves the list, and then we retrieve a long description, of the save video tool or the save video function. And similarly for the other tools, closest box distance to measure the distance between the shark and the surfer. And then based on that, we end up generating code, fully automatically generated, that when run, results in the video that you just saw. Right? So I'd like to just dive a little bit deeper into how this works. So we built the vision agent to work as follows. You input a prompt. This is a slightly simpler prompt than the one I used just now, but calculate the distance between the shark and the nearest surfboard. And the goal of our vision agent is to write code to carry out the task that you prompted it to, so that you can then feed it a single image and have it generate the desired outcome. And similar to agentic workflows on writing non-image code, we find that this works much better than zero-shot prompting for many applications. Moreover, we found that for a lot of image users, for example, if in Snowflake you have 100,000 images, then having code that you can very efficiently run on a very large set of images is important too, because once you have the code, you can take a large stack of images or maybe video frames or whatever and run it through a relatively efficient piece of code to process and get the answers. And I want to share with you how our vision agent works, and it's open source. So take a look, give us feedback, maybe help us improve it. But the vision agent is built with two agents, a coder agent and then also a tester agent. But with a prompt like this, a coder agent first runs a planner to build a plan that lists out the steps needed to complete the task. So, load the image, use the tool to detect the object, calculate the distance, and so on. And then it retrieves a detailed description of each of these tools. Tools means functions. And then finally, generate the code, right? And I don't know if some of this seems a little bit too magical almost, but all the code is on GitHub. Take a look at it, take a look at the specific prompts we use. You might be surprised when you look at the details how, all of this stuff seems magical maybe the first time, but look at the code and look at the prompts and it turns out that when you do this, here are a few other demos. This says detect every person in this image, figure shows wearing a mask, output a Python dictionary. So generates a bunch of code. Here's a Python dictionary, 8 people are masked, 2 people are unmasked. Or here's a different prompt to actually generate a visualization, plot the detections, and so on. So this is a new piece of code, all automatically generated. And I actually missed the unmasked people, the object detection thing, found the unmasked people. One more example. Oh, this one's kind of fun. Analyze the video every 2 seconds, classify if there's a car crash or not, output JSON, showing is there a car crash or not. So car crash videos are always, well, I don't think anyone was hurt, but 16-second video. It's coming. There's a car. Fortunately, no one was hurt, I think. And if you do that, here's the code on the right. And it processes the video and outputs the JSON showing, at this timestamp, there was no car crash. At this timestamp, there was a car crash. Right? And so the feedback I'm hearing from quite a lot of people, from my internal team and some users is, yeah, I could have written the code myself, but it would have taken me a few hours and you can now get this done. I find that in computer vision, we use lots of different functions, and honestly, I can never remember, right? What function to use, what's the syntax, and this really makes the process of building visual AI applications much easier when it works. And I want to share just one other thing that makes the performance better, which is use the tester agent. So I showed you the coder agent, and it turns out that you can prompt an LLM to say, write some tests for this, and or write text code. And based on that, it can execute the test code. Right now, our test code is often type checking, so it's a little bit limited, frankly. But even with that, we can execute the test code, and if the test code fails, feed the output back to the coder agent, have it do a reflection and rewrite the code, and this gives it a further performance boost. Oh, and I should say, in terms of academic literature, the 2 research papers that we counted on the most is the agent coder paper by Huang et al., and then also the data interpreter paper by Hong et al. So you can take a look at those papers if you want to learn more about these techniques. And so just to show one last demo This says, can you detect the cost and mobile device sends video every 2 seconds? We wanted it to highlight, so this is actually for CCTV videos, kind of put together into a video. Common thing people want is to just highlight the interesting parts to look at. It's a long prompt YouTube link, so it creates instructions, like so, retrieves tools. It turns out the code doesn't work, right? So the code, maybe I'll show you this one. The code actually fails a few times. Here, when running it, there's an index error, trace back. So we feed all these error messages back to the LLM, fails the second time, fails the third time. It turns out the third time it fails, no module named PyTube. And so the last thing that fixes it is it's figured out, to do pip install PyTube. And then this actually fixes it, runs the code, and then you have this kind of, highlighting in the CCTV agglomerated video, which of the 4 videos has more than 10 vehicles and that you should look at, right? So, I'm excited about Agentic AI as a direction for many applications, including coding and vision and the visual agent, which is what we've been working on. Just to share some limitations, it is very, very far from working all the time. In our experiments, 2 failures, probably one of the most common failures. We use a generic object detection system, grounding Dino, that sometimes fails to detect objects. Here is miss a bunch of yellow tomatoes, common failure. One of the things I was excited about Landing Eyes collaboration with Snowflake was we recently built Landing Lens, which is a supervised learning computer vision system as a Snowflake native app. But I think with supervised learning, we were able to mitigate some of these errors. And then, it's not good at complex reasoning. So here, if you say each bird weighs half a kilogram, how much weight is on the fence? With this example, system naively detects all the birds, but doesn't realize that one of the birds is flying and won't put weight on the fence. But it turns out if you modify the prompt to say ignore the flying birds, it actually gets it right. And I feel like today, Vision Agent, we're releasing it in beta. It sometimes works, sometimes doesn't work. It's a little bit finicky to the wording of the prompt, and sometimes you do need to tune the prompt to be more specific about the step-by-step process. So I wouldn't say this is, brilliant, amazing software, but sometimes it works, and it works. I've been really delighted and amazed by the results. I just mentioned, hey guys, you stand up. The team that built the Vision Agent is actually here today. Dylan's a surfer, standing in the middle, and Asian Shankar. So I hope you catch them. You will learn more about this either here or at the Landing AI booth, and is also online at va.landing.ai, and is also released a core engine as open source. And I feel like AI agents is very important, exciting trend, and we're making this small contribution to open source to hopefully help everyone. And I hope that together we can make agents much better, and this will significantly improve what we could all do as developers. So with that, let me say thank you all very much. Thank you.